Hey everyone, and welcome to The Explainer. Today, we're going on a massive cosmic journey. We're stepping way beyond those standard textbook facts to truly understand the sheer scale, the bizarre beauty, and frankly, the absolute terror of Jupiter. If you think you know the gas giant, well, buckle up, because we are going deep into the belly of the beast.
Okay, let's dive right into this. What would actually happen if you just fell into the largest planet in our solar system? It's a terrifying hypothetical scenario, isn't it? But before we take that plunge, and trust me, we will, we really need to wrap our heads around the mind-bending scale of the planet we're about to explore. Because to understand what happens when you fall in, you first have to grasp just how massive this world truly is.
318. That's how many times more massive Jupiter is than Earth. It's an absolute behemoth. In fact, it holds 2.5 times the mass of all the other planets in our entire solar system combined. You could literally fit over 1,300 Earths inside it. It's so massive that its gravity basically dictates the orbital mechanics of our entire planetary neighborhood.
To really put that into perspective, let's contrast it directly with home. Earth gives us a solid, rocky surface to stand on and a nice, leisurely 24-hour day. Jupiter, on the other hand, is a swirling mass of gas and liquid with absolutely no true surface to speak of. But here's the truly mind-blowing part. Despite being 318 times more massive, Jupiter has the shortest day in the solar system. It spins so incredibly fast that its day is less than 10 hours long. That rapid rotation is exactly what whips up the planet's intense weather and those iconic swirling cloud bands we all recognize.
Section 1. King of the Planets.
And this brilliantly illustrates a really common myth. You've probably heard people call Jupiter a failed star. It's true that it's made of the exact same basic ingredients as the Sun, mostly hydrogen and helium. But to actually ignite nuclear fusion and become a true star, an object needs to be at least 75 to 80 times more massive than Jupiter. Even a brown dwarf, which can fuse deuterium, needs 13 times Jupiter's mass. So while it's a planetary giant, it falls way short of being a failed star. Actually, scratch that. It's not a failure at all. It's exactly what it's supposed to be, the ultimate gas giant.
Section 2. Friend or cosmic foe.
Jupiter has famously earned the nickname the vacuum cleaner of the solar system. Its immense gravity actively pulls in stray space debris. We saw this demonstrated spectacularly back in 1994 when the comet Shoemaker-Levy 9 was torn apart and crashed directly into Jupiter's southern hemisphere. Those impact scars left in the clouds, some of them were larger than the entire Earth. It's estimated that objects hit Jupiter thousands of times more often than they hit us.
So, Jupiter acts like a massive cosmic goalkeeper, but one with a very dual nature. On one hand, it protects us by sucking up dangerous debris and stabilizing the main asteroid belt. It can even catch incoming comets from the distant Oort cloud and slingshot them entirely out of the solar system. But because gravity is a two-way street, it can also alter the orbits of objects that stray just a bit too close. Sometimes, it can accidentally hurl short-period asteroids directly toward the inner planets, including Earth. So it's our protector for sure, but also a potential threat. Honestly, without Jupiter acting as our cosmic bouncer, complex life on Earth might never have had the stability to evolve in the first place.
Section 3. Diving into the giant. But before we even begin to fall, we got to navigate past this absolute monster, the Great Red Spot. It looks beautiful from a distance, right? But up close, it's a swirling, chaotic mass of hydrogen and helium gas that is wider than the Earth itself. It's a storm that's been raging for at least 350 years. And recent data from the Juno spacecraft reveals that this storm plunges an incredible 300 miles deep into the planet. It's a hurricane that makes our worst Earth storms look like a pleasant spring breeze.
Let's move to the descent and see how this builds. First, as you hit the top of the atmosphere, you're falling at 180,000 kilometers per hour, just pulled by that massive Jovian gravity. You immediately hit freezing ammonia clouds at minus 150 degrees Celsius, getting completely battered by winds whipping at nearly 500 kilometers per hour. As you fall deeper, the sunlight fades entirely. You're in a pitch-black descent, illuminated only by these colossal lightning flashes. Eventually, the pressure builds so intensely that the gas turns into a supercritical fluid, this bizarre state of matter you'd almost have to swim through. And finally, you're trapped in a dense, inescapable ocean of liquid metallic hydrogen, where the pressure is literally millions of times what we feel on Earth. And if you somehow had a magic spaceship that survived all that, well, you'd eventually hit the core region, Here, the temperature is estimated to be 36,000 degrees Fahrenheit. No way, right? That is hotter than the surface of the sun. And the pressure is roughly 2 million times that of Earth's surface. Scientists now believe this core isn't even a solid ball of rock, but rather a fuzzy, partially dissolved mix of heavy elements, blending seamlessly into the metallic hydrogen ocean above it. It is just an incredibly hostile, extreme environment.
Section 4. A mini-solar system.
Currently, Jupiter has 95 officially recognized moons. 95. This number actually keeps growing as our technology gets better at spotting tiny objects caught in its orbit. But among these 95, there are 4 that absolutely steal the show. Worlds so complex and fascinating, they could easily be planets in their own right.
Now, what's really interesting about this group is the extreme diversity of these 4 Galilean moons, which were discovered by Galileo himself back in 1610. Think about Io, caught in this brutal gravitational tug-of-war. It's the most volcanically active body in the solar system, literally covered in lakes of lava. Then there's Europa, an icy shell hiding a vast warm liquid water ocean beneath its surface. Ganymede is actually larger than the planet Mercury, and is the only moon in our solar system known to generate its own magnetic field. And finally, Callisto, a frozen, ancient time capsule, boasting the most heavily cratered surface we know of. 4 moons, 4 completely different alien worlds, right in our backyard.
Section 5. Exploring the unknown.
We are currently on the cusp of a thrilling new era of discovery. The European Space Agency launched the JUICE mission, which stands for Jupiter Icy Moons Explorer. Launched in April 2023, this incredibly ambitious spacecraft is on a long, winding journey, set to arrive at the Jupiter system in the year 2030. Once there, it's going to spend over 3 years in a complex orbital dance, studying Jupiter's wild environment and taking a very close, detailed look at the habitability of Ganymede, Callisto, and Europa.
Which leaves us with this provocative final thought. As we stare up at the night sky, we have to wonder, when JUICE finally arrives and its instruments peer deep beneath the ice, what will it find? With an ocean potentially holding twice as much water as all of Earth's oceans combined, kept warm by the endless tidal friction of Jupiter's immense gravity, could alien life be swimming in the dark, warm subsurface ocean of Europa right now? It's a question that could change our understanding of life and our place in the universe forever. Thank you so much for joining me on this explainer. Keep looking up and keep asking questions.